Question 4 students, for the case study, a lighthouse stands tall on a cliff by the sea, watching over ships that pass by. One day, a ship is seen approaching the shore, and from the top of the lighthouse, the angle of depression of the ship are observed to be 30° and 45° as it moves from point P to point Q. The height of the lighthouse is 50 meter. So here students, if you observe this figure carefully, then here see that this is the, suppose this is the horizontal line, we draw the horizontal line, and here that this is the base of the lighthouse. This is the base of the lighthouse, and here we draw the AB. We draw the AB as the AB represent the line as for the height of the lighthouse. Height of the lighthouse. And the height of the lighthouse is here students 50 meter. See here, that is the 50 meter. So here AB represent the height of the lighthouse. And here students, first there is a, suppose there from the top of the lighthouse. The B represent the top of the lighthouse. And we observe the ship. We observe the ship. Okay. That from this point, first we observe the ship, but there will be the angle of depression. The angle of depression, and from the position, this will be the horizontal line. Okay. And that XB represent the horizontal line with respect to the top of the lighthouse B. So now the angle of depression, that means here, suppose the ship is at the position P, at the position P. Ship coming from the position P. When that ship is at the position P, then the angle of depression becomes the angle of depression. Please, my students, see the angle of depression will be 30°. This way, the 30°. Okay, the angle of depression, that is XBP, will be 30°. Now here students, that then the ship slowly come at the point Q. That is, it come towards the base of the lighthouse. Then first it come at the position Q. It come at position Q. And when it come at position Q, then the angle of depression, becomes 45°. Students, that angle of depression will be 45°. Okay, students. And then here, as per the given information, we have to find out the questions. Based on the information given above, answer the following questions. First, find the distance of the ship from the base of the lighthouse when it is at point Q, where the angle of depression is Q. Okay, students? So now here, as per the given information, we have to find out the distance of the ship from the base of the lighthouse. Okay, the distance, we have to find out the distance of the ship from the base of the lighthouse where it is when it is at point Q. Okay, that point Q, from the point Q, we have to find out the distance. So that means here we have to find out the distance AQ. We have to find out the distance AQ, students. Okay, so now here we have to choose the right angle triangle ABQ. Okay, we have to choose the in right angle triangle. In right angle triangle BAQ. Here BAQ. Now here students, observe the figure carefully. If you observe this figure, this triangle BAQ, then here at the ground level, this angle is 90°. Okay, and here students, here that the angle of depression, this angle of depression, this one, that is a XBQ. The angle of depression XBQ is 45°, and the XB and PA are parallel to each other. XB and PA are parallel to each other, and that's why by the alternate angle property, that HBQ is equal to 45 degree, and that means BQA is also equal to 45 degree. Okay students, and as per 45 degree, then we have to calculate, that is the QA. Now here AB, students, here AB is the distance of AB, that is the lighthouse, that is the height of the lighthouse. Okay, AB is the height of the lighthouse, and that is given as the 50 meter. Okay, that is the 50 meter, students. So that's why here, that in right angle triangle BAQ, that we use the tan property, tan 45 degree. Okay, the tan ratio, we use here the tan ratio because we have the opposite side of angle 45 and we have to calculate the adjacent side. So now here in the tan ratio, there are the two ratios. There are the two sides are the mentioned, adjacent side and the opposite side. So here we use the tan ratio, that is the opposite side of angle 45 degree divided by adjacent side of angle 45 degree, and that is opposite side of angle 45 degree, that is equal to AB, and adjacent side of angle 45 degree is QA, and tan 45 is equal to 1. So here 1 is equal to opposite side AB, that is equal to 50 meter. So here I write 50, and that's why QA. So now here, that is QA is equal to 50, and that is 50 meter. So here we can say that the distance of the ship from the base of the lighthouse when it is at Q is equal to QA, which is equal to 50 meter. And the measure of angle PBA and angle QBA. So now here students, in this figure, see here, in this figure, we have to find out the angle. Here the angle QBA. Okay, we have to find the angle QBA, and as well as the students, we have to find out the angle, that is the angle PBA. Okay, first here students, we choose the triangle. We have to find out the angle QBA, and the angle QBA, this one angle, this angle comes in the triangle QBA. So we write here, first we choose the angle QBA, that is in triangle QBA, angle Q plus angle B plus angle A is equal to 180 degree. Okay, the sum of the angle property. So now here we know that the angle Q, how can we get the angle Q? Because the angle of depression, this angle of depression, when the ship is at position Q, the ship is approached at the position Q, then the angle of depression is 45, then XB parallel to PA, so that's why it is also 45 degree. Okay students, this is 45 degree, and this angle, that is the angle made by the lighthouse, is also is equal to 90 degree. So here we can substitute these angles, the values of these angles, that is the Q is equal to 45 degree. Angle B, we have to calculate angle B means the angle QBA, plus angle A is 90 degree students, so here 180. So now angle QBA plus here 135 is equal to 180. So now angle QBA is equal to 180 minus 135. Okay, so now here angle QBA is equal to, that is 5, and here 45 degree. Okay, so now angle QBA is equal to 45 degrees students. Now here we have to calculate angle PBA, So now angle PBA, how can we calculate the angle PBA students? The angle PBA is calculated, see here, angle PBA, that is the addition of both the angles. the addition of angle PBQ, plus angle QBA, Now here students, the angle QBA, we know that the angle QBA is equal to 45 degree. Okay, we calculate here. But now here angle PBQ. How can we calculate this angle? Okay, PBQ. So now PBQ, this angle, we can get this angle as the angle here. See here, the angle as this angle as this one angle, totally this angle, that is the 45 degree also. Okay, that angle here also 45 degree, and this one angle, that is a 30 degree. So that means 45 minus 30. 45 minus 30. So that means equal to 15. 15 plus 45 degree. Okay student? So that means here the angle is 60 degree. So angle PBA is equal to 60 degree. Okay students? Find the distance traveled by the sheet between points P and Q. Okay student? So here first we have to calculate the distance PQ. We have to calculate the distance PQ. Okay? So the PQ, see here students in this figure that PQ consists in the right angle triangle BAP. Okay, it is in the triangle BPQ, but here we want the right angle triangle. So it is in the right angle triangle BAP. So we choose that. In right angle triangle, in right angle triangle BAP. Okay. So now here we know this side and also this side. This, if you find out that the PQ, we have to find out the side PQ, then that's why this is the opposite side and this one is the adjacent side to this angle P. So I choose here tan 30 because the angle P is 30 degrees. So tan 30 is equal to AB, the opposite side upon the adjacent side PA. So now here tan 30 is 1 upon root 3 and AB is the 50 upon PA. Okay. So now here PA is equal to 50 root 3. Okay. PA is equal to 50 root 3 meter. So now here we have to calculate the PQ. So how can we calculate the PQ? We calculate the PQ as the PA minus QA. So now PA is the 50 root 3. 50 root 3 minus QA is the 50. So now here students, common is 50, then root 3 minus 1. So here PQ is equal to 50 root 3 minus 1 meter. Okay, this way. So here students, the distance traveled by the sheet between points P and Q is equal to 50 in the bracket root 3 minus 1 meter. Well student, next example. If the sheet continues moving towards the shore and takes 10 minutes to travel from Q to A, calculate the speed of the sheet in km per hour from Q to A. Okay here students? So students, that we have to calculate the speed of the sheet. And here we know that is the speed, the formula for the speed. Here speed of the sheet and the formula for the sheet, speed is equal to distance upon time. And the distance is from students, that is the Q to A. The distance is from Q to A here. Okay, that is from here to here. And the distance is 50 meter. So that distance from Q to A. Okay, so the distance is 50 meter and the time. That time is here given, that is the 10 minutes. Takes 10 minutes. So here the 10 minutes. So now here the question wants the speed of the sheet in kilometer per hour. So we convert this meter and minute. So here 50 divided by 1000 kilometer, and here in the minute that we have to convert into the hour. Okay. So that means here that we convert that in kilometer per hour. So that is 50 upon upon 1000 multiply here reciprocal of this, that is 60 upon 10. Okay student, so that's why now here 0 0, here 0 0 get cancelled, then 5 ones are 5 2s are 10, here 2 ones are 2 3s are 6. Okay, so now here student, that is the speed is equal to speed of the sheep, speed of the sheep is equal to 3 upon 10, 3 upon 10, and which is equal to 0.3, and which is in kilometer per hour, that is equal to 0.3 kilometer per hour. Okay, so this is our final answer.